button. So hi everyone. So as you've heard, my name is Florian. I'm a solution architect organizing this meetup for the island user group for OpenShift. We have two speakers today, Jeff and Sean from Ammeon, and then we have Anton from IBM talking about Node.JS. So I'm just going to hand over directly to Jeff because I know he is very keen on introducing himself and Sean. So yeah, there you go.
Hi guys, so I'm Jeff, work for a company called Ammeon. So we are Dublin based, although you can probably tell by my accent, I am not Dublin based. I'm over here in the UK in Reading. Just really, in case no one's heard of the name, Ammeon, we are kind of premier partners. We've got expertise in Ansible, OpenShift and OpenStack, and we are container platform specialists, Red Hat branded even. Like I say, headquartered in Dublin. Historically, we've been very much involved in telco market and kind of providing services to some of the larger telco firms around the world. But we've recently been bought by a firm called Intiv, who are a global firm rather than just kind of UK and Ireland. Should give a lot more reach and a much broader markets. Intiv, like I say, global company, specializing in designing and engineering kind of digital products, like the whole life cycle. From inception through to support, and that is, I'm sure Florian will be glad to know that is it. There's no bigger sales pitch than that. Just a bit of background really, and so sort of following on from that, presentation today is going to be from Sean, one of the DevOps consultants for Ammeon. Now Intiv, who's worked on all of the mentioned technologies, Ansible, OpenShift and OpenStack, and so is well positioned to give you a good insight into our OpenShift and OpenStack lab.
Cool.
So without further ado, Sean, I'll hand it over to you.
Cheers, Jeff. Yeah, thanks, Florian, for having me, and thanks everyone for joining. Hopefully you get something out of the presentation. But I'll share my screen so we can start. It says host disabled screen sharing, Florian.
I knew this was what happened. Just give me a second.
No problem.
First time I'm using Zoom, so give me some slack on this one.
It's your first day, Florian. But yeah, while we're sorting out, basically, let's give you an overview of what the presentation will be about. So we've got OpenStack 13 in our internal lab. So we face some challenges with trying to spin up multiple instances. Start the video.
You exit now?
No, still disabled, Florian.
I'm just going to make you host.
Ooh,
don't tell anyone. Yeah, just give it back to me once you're done.
Yeah. Perfect. Thank you, Florian. There we go. Okay. And hide and present. Hopefully you should be able to see my screen.
Yep.
Perfect. Okay, yeah, so as I said, it's OpenShift 4.6 on OpenStack 13. So to kind of bring you through the whole deployment, I'll give you a brief overview of the Ammeon lab. I mean, it's not super important in this context, but we'll give you a bit of background information of where and on what we're deploying OpenStack and OpenShift. Then I'll talk about the Ansible code and inventories and how we've arranged them and why. So yeah, start off with a kind of a topological bird's eye view, if you like, and we can kind of dig into the inventories then as well and show you the benefits of what we've done and some of the reasons why we've done what we've done as well. Following that, I'll give you a little walkthrough of the deployment in action. We'll walk through. There'll be screenshots of the various sections of the Ansible code itself. It's not going to be a live deployment. And at the end, well, a little bit throughout, I'll talk about some of the challenges and workarounds, but at the end, then I'll kind of summarize, some of the challenges and workarounds we faced coming up with the developing this automation. And at the end, then some room for Q&A if anyone has any questions. Or okay, let's get started. So the Ammeon lab, it's based on Supermicro hardware. There is, I believe, 7 blades in there. So 1 dedicated to director, and the other remaining 6 then are the compute and control nodes. So it was originally deployed using Kolla Ansible. So it's, as I said, it's kind of an internal lab, so it's used for POC, proof of concept, our own kind of R&D in various technologies, and again, testing our own automation code, whether that be kind of pre-deployment on customer sites, or we're kind of developing our own automation, which this case is. Okay, so the Ansible code itself, this is a kind of top-down view. So basically, it's split into kind of 2 main repos. One is the code on the right. So in here we have all the roles, playbooks, etc. And what we've done is the entire code is parameterized. So there's no, there's no vars in any of the roles that need to be changed to run any of this. Everything is parameterized in there. And then outside of that, in the other repo, we have our inventories in our vault. So as you can see in the vault, obviously your SSH keys, your certs, your passwords, the usual stuff. And in the inventory, then we've kind of broken that down into, well, I'll just go to the next slide. It's easier to explain. So this is inside the inventory. So you can see here we have our OCP side and we have our OpenStack side. So on the OpenStack side, that means basically that you can point to any instance of OpenStack. You just have to have your, your hosts, your group vars, the usual stuff filled out. So now it says Dell, Parage, and Supermicro here, but you can see that could easily be dev, staging, prod, such that you could deploy your same instance of OpenShift, but you could deploy it against, as I said, dev, staging, or prod with a simple -i invocation of whichever OpenStack cluster you want to target. The reason we did this originally, what we had in Ammeon was a kind of a monolithic repo. So everything was in one repo. We had one repo for the inventory. We had one repo for the code. The code itself had a lot of vars files in the roles, which meant there was a lot of room for error. Which, at worst case, the Ansible would fail. Sorry, best case, the Ansible would fail. Worst case, you could actually end up destroying an existing OpenShift cluster, which was not a good thing. So that's why we had separated out the various inventories like we have here. So there's 2 main sections to the Ansible code itself. One is OpenStack, and the second here is obviously OpenShift. So what the OpenStack side of proceedings does, it does everything in OpenStack required such that OpenShift can be deployed. So what I mean by that, it creates the tenancy, it creates the user, it creates all the quotas, the flavors required for the VMs, it uploads the CoreOS images to Glance, creates the security groups, the floating IPs, the network, the usual stuff you see there. OpenShift then itself, so what it does, it pulls down the OC binaries to your deployment machine, invokes the IPI cluster create command, monitors the deployment process, and then syncs the authentication credentials to your deployment machine, like your kube config. So a couple of challenges we faced, particularly on the OpenStack side. We found some of the Ansible modules lacking in some areas, let's say. So things like creating floating IPs was non-trivial. And the reason for that is there's no, well, at least at the time of developing these scripts, there was no Ansible module that could create a floating IP as a standalone resource. The only way to create a floating IP using traditional Ansible modules was to create a VM, associate a floating IP, and then kill the VM but keep the floating IP, which is quite a bit clunky. So what we had to end up doing was writing a custom URI call using the Ansible URI module, and that would then directly interface with the OpenStack API. But before that, yeah, it was quite clunky. Similarly with DNS, there's no DNS as a service in OpenStack 13. So it meant then we were kind of facing a chicken and egg scenario when it came to deploying the cluster, because the cluster needs to know the IPs of various VMs as it builds. But if there's no DNS there, it can't reach them. But of course, you don't know the IPs until you deploy the cluster to fill out your DNS. So what we did there was, as I said, create the floating IPs first using the API, and then use that to build a DNS host and inject those IPs into the DNS server itself, and then the cluster could come up knowing what IPs.
Mom's canoe, yes.
So if we move along, so this is just kind of the deployment environment to the local deployment environment. So it's just the versions of what
Last night I was moving stuff
we were using.
up a couple feet in the air, just in case, because the sump pump was basically.
So can you mute Bill, maybe?
Yes, thank you. No worries. Yes, as I said, that was just kind of the
Depends on your drainage. So
deployment
like,
environment.
people up the hill from us, they have a flooded basement.
So this is what the kind of
Drainage is-
top level playbook looks like.
John, you'll have to mute him. Your host.
Oh, it's me. I see. Okay.
Yeah,
Okay,
yeah,
well,
I hand
I
it
will,
over to you.
Circle back. Yep.
Okay. But how do I mute myself without muting myself, as it were?
Okay. Yep. Sounds good. Thanks.
I think you just hover over him and mute him in the.
I got you. Okay.
When you go, you have downstairs a row of participants as well. When you go down, left. Participants.
Here?
Yeah.
This guy, was it? Here we go. The power.
That's not TikTok.
Yeah.
That thing just
It's Bill down there. Yeah. There you go.
There we go. Okay. Sorry about that, folks. Okay. You can still see my screen?
Yeah.
Perfect. Okay, yeah, so the top level playbook looks like this. So what it does is just imports several kind of sub playbooks, if you like. So as I say, the prepare playbook will do everything in OpenStack, like I said, the tenancy, the users, quotas, flavors, etc. And the floating IPs. So DNS then will create that DNS host. It will take in the floating IPs that were created, and it will build up the DNS server basically based off that. Following off from that, then the deploy scripts will invoke the API installer, which will then kick off the bootstrap machine, which will then do its business and create the masters and worker nodes. So just to call out here at the bottom, so this is what it looks like when you call the playbooks with two inventories. So here we have our OpenShift projects that we're taking in, and also which OpenStack cluster we're deploying against. So yeah, as I said, those can change and quite easily once, and you don't have to change the Ansible code. You just have to create the inventory and the code will take over, or will handle the rest. So here we just a quick dive into one of the roles. So this is creating the subnets for the project. So as you can see, it's completely parameterized. Everything here is in the inventory. And as I said, the benefit of that then it just rules out any potential sources of error, any kind of conflicting subnet creation. Everything is in inventory. So if you're deploying a new cluster, you just have to look at the inventory. That's it. The code will do the rest. And again, so just this side here is just what it does. It pulls down credentials to your deployment machine. So it will give you your auth URL, password, domain, etc., usual OpenStack stuff. And again, yeah, so IPI and Terraform will use that then to actually log into OpenStack and deploy. So this is kind of what it looks like, again, from a kind of a topological level. So we've kicked off the prepare playbook here. So as I said, the we're creating a couple of floating IPs. We're obviously creating the API IP, the app IP, and the DNS server itself IP. And again, all of that is created using the Ansible URI module and some custom Python that was authored by a colleague of mine who I believe is on the call. Hello, Brian. But yeah, so as I said, the reason for that is there's no native, at least at the time of development, Ansible module that could do that for us. So yeah, so it creates the DNS. So if we go moving on to the deploy section. So effectively, once your DNS, etc., is all set up, you've set up your OpenStack environment, you're ready now to kick off that IPI installer. And as with OpenShift, Bootstrap machine comes up first, does its bits, and once it's all finished, you have a complete OpenShift cluster on OpenStack, all automated. If we move on, so here's kind of an overview of the timings. So a full deployment from kicking off the top level playbook. So that's going from a blank OpenStack tenancy to having a fully functioning OpenShift cluster is an hour and a half. The bootstrapping itself is 40 minutes. The cluster operators coming up is another 32, and then the OCP API takes another 15 minutes or so to come up. So a little bit long in some parts, but I mean, you know, to do all this stuff manually would take you a lot longer. So again, just to kind of walk through some of the challenges. As I said, it was originally monolithic, which caused a lot of, well, I won't say a lot of, but some problems when we were trying to deploy separate OpenShift clusters. As I said, with the mix match, with some subnets declared within the Ansible code, it meant that there's a lot of files, etc., to check that you were making a unique cluster. So pulling out all of that into the inventory saved a lot of headaches. Another issue we had was some of the code wasn't idempotent. So which meant then if the Ansible failed and you need to rerun again, you'd hit issues in OpenStack where it would try to create the subnet again, for example. But obviously OpenStack won't let you do that because it won't let you create, state subnet. So it meant then you had to go into OpenStack, go in, tear down manually anything that had been created by the Ansible manually, which just added a load of overhead. So yeah, creating idempotent code, vital. So again, as I said, some of the functionality was lacking in the Ansible modules. And I'm not sure, I haven't looked since, well, not since, but recently, I'm not sure if that's changed. I do know, or at least I believe, OpenStack 16 has DNS as a service now, which solves a lot of the problems we were having with DNS. So that's pretty much it in a nutshell. Like, I guess a lot to unpack in that, but yeah, any questions or any thoughts, or would you like me to kind of go through something in a bit more detail? Or
do you have them available open source, or are they just available within Ammeon the playbooks?
It's just available within Ammeon at the moment. Yeah,
okay.
I'm not sure if there are plans to open source it.
Yeah, I find it quite interesting.
Yes, yeah. It was it's definitely, it was the main takeaway, I guess, in terms of usefulness, Florian, was separating out those inventories.
Yeah,
because it makes it kind of, well, to be honest, trivial to deploy any number of OpenShift clusters on any number of OpenStack targets, you know.
And did you use also playbooks to automate day one steps like configuration, for example, of Active Directory or other integrations?
No.
Okay, so this just
it's just setting up the infrastructure, as it were.
Okay.
And OpenShift itself, but yeah, there was no code there for setting up, let's say, users or whatever in OpenShift itself, anything like that.
Did you run? Cheers, thanks for the talk, by the way. Did you run any workloads after sort of on top of that? And how did OpenShift actually behave on top of OpenStack? Is it is it well behaved, and did you run any workloads? I think that's the two
We
questions.
did indeed, yeah. So yeah, so the reason, as I said, for kind of developing this stuff was we run a lot of POC stuff internally, and OpenShift is a fairly large part of that. And yeah, so there is a couple of workloads running on top of the existing OpenShift that has been deployed with this code. We've had hardware issues with the Supermicros, so that's caused a lot of issues. But outside of that, yeah, OpenShift seems to run quite well. Now we don't have any let's say laborious workloads. We've a few applications sitting on those OpenShift nodes, but nothing super taxing, let's say, in terms of resources.
Okay. Are there any other questions? Okay, it doesn't look like it. Sean, if you would hand over the admin
Controls.
controls back to me.
Yeah, sure. Can you direct me, Florian? Where's?
Oh, Jesus. I would say hover over my icon on the right. If you go to Florian Moss, and then just more, and then just
yes,
make host.
Make host.
Yeah.
Perfect.
There we are. So a couple of people that I need to admit here. Perfect. There's a couple more people that were in the waiting room, so sorry about that. I'll find a way to hand over now to you, Anton, without making you host, maybe. I always thought that Zoom was supposed to be so intuitive, but it's definitely not that intuitive. I'll just make you host again. It's easier for me. All right, I made you as host, Anton, so you can take over and start with your presentation.
Okay, let me jump in. So can we see that okay now?
Yep, I can see that.
Right, okay. So hi everybody. I'm Anton Morley. I'm a technical partner architect in IBM, and basically I help IBM partners adopt and bring IBM technology to their customers. Okay. As a sort of a night job, or my other job in IBM is working alongside working with Red Hat and the Red Hat architecture team to build out some of our go-to-market around Node.JS and how it works with Red Hat technologies and IBM technologies, and that's really what I want to share with you today, because we're making some growth. It's been a project that's been running for around 18 months, and we're getting to the point now where we've got some assets and some thoughts that we're bringing and we're releasing out, publishing it out on GitHub. Just want to walk you through that. Okay, so I'm going to talk a little bit about just give some motivation. Why are we talking about Node.js and JavaScript on OpenShift? Want to step you through the GitHub repo just to show you where it is, the types of things that are in there, and then just walk you through some of the new features that are coming to OpenShift that we're pretty excited about in terms of serverless and some of the new, like I say, some of the new features that are in OpenShift that we're supporting as well. Okay, so I guess to start off with, then, when we talk about running Node.js on a containerized environment, we see sort of pretty good benefits in terms when you compare it to sort of your standard Java type applications. So we see sort of half the memory requirements, sort of half the CPU requirement for sort of equivalent workloads. So what we're looking at here is Spring Boot running one of the standard templates versus Node.js running as a Node.js Express application, which is two, So again, it's not particularly scientific, but it is sort of it's what I've seen when I've been working with customers, and it is kind of accepted that Node.js runs with higher density within a OpenShift environment. Okay, and there's good reasons for that. I'd say the main reason for it is people forget, or people aren't quite aware, that Node.js was actually designed to run within a containerized environment. The first project sponsor for Node.js was a company called Giants. They had Solaris Zones at the time, which was a container technology for Solaris. So their target deployment was always operating system level virtualization as opposed to hardware level virtualization. So they wanted things like fast startup time, lightweight footprint, easy configuration, inbuilt package management as a first-class citizen within their runtime, within the JavaScript runtime, within Node.js. And because of that, those benefits have been picked up by the Linux operating system level virtualization, containers, if you want to, and that is a benefit that then has been passed on to OpenShift. Okay, so that's sort of one of a few of the main reasons why we're seeing folks look at the adopting Node.js alongside the sort of standard development approaches that they have within their enterprises. Okay, some other reasons. There is obviously the language. JavaScript is just everywhere. It's the most ubiquitous language, and it also has a substantial sort of ecosystem. Also a bit Achilles heel, the ecosystem. As you can see there, there's over 1 million packages within the Node.js ecosystem. But in terms of understanding how much adoption Node has and is continuing to have, it's interesting to look at that curve as it goes, sort of grows almost exponentially when compared to all your NuGets, your .NETs, your PHPs, Python, etc., etc. Okay, so and then that's the ecosystem, and what we're seeing within certainly between the open source community and what we're seeing in Red Hat is that we're getting huge numbers in terms of downloads. There's 184 million downloads like in Q2 this year of Node.js. The massive numbers really, and just over 9 even from the UBI registry, which wouldn't be quite as well known. The Red Hat registry, we've still got 500,000 downloads there for Q2. So it is, Node.js is used absolutely everywhere within enterprises and across the ecosystem. And as well as sort of our customers using it, IBM drives a huge part of its cloud platform based on Node.js. Our cloud.ibm.com runs off it, Weather Company runs off it. We've got a huge amount of adoption within our own organization. So we do dog food Node.js a lot, which is why we sort of want to encourage everybody to use the technology, because we've seen the benefits of it. And as I mentioned previously, it sits well with containers, container environments, with OpenShift, and it plays really, really well in serverless. And I'll get to that more in a bit. Okay. In terms of enterprise usage, it's used everywhere. All the big brands have some sort of deployment footprint, and it's almost as if you also want to consider the command lines that come with Node.js as well. So all the web front-end frameworks, React, Vue, etc., they're all driven by Node.js. You could probably argue that 100% of the world's companies who are on the web are using Node.js, but certainly from a back-end technology, these are the folks that are sort of in the middle. So Amazon, Netflix, ourselves at IBM, you get the banks in there, etc., etc. So it's a huge option across the enterprise, and it's if you are working or looking, if your front-end devs are looking to use OpenShift with their technology, with the technology based on JavaScript, then you absolutely have the full support of Red Hat and IBM in order to support that adoption within your organization. Okay, so that's a bit of a sort of the reasons why. What I want to do now is jump into the reference architecture. Okay, so what we've done is we've gathered together all the different experiences, both within IBM, from the teams that I mentioned, from within Red Hat, and from the customers that we're engaging with, in order to put together a set of recommendations and practices people are actually using. So as I mentioned, there's over 1 million packages. If you go and you understand the benefits of using Node.js on OpenShift, and then you start to look at that ecosystem to say, which ones should I use? It can be very, very daunting. So what we did is across 2 organizations was basically put together an opinion based on those experiences in order to find some sensible defaults for people looking to adopt Node.js. Okay, so I think the key thing about this is to remember that it's an opinion. But we're definitely not what we're trying to do here is sort of bless one package over another package, or put more influence folks that are using OpenShift, but to the wider ecosystem as well. But again, the real intention is it's not opinionated. It's actually quite important. So what's actually in the reference architecture? DBs, how to do scaling, etc., etc. And then sort of best practices in terms of development. How do you build good containers, static assets code, and then we also provide some guidance on operations in terms of monitoring, logging, and problem determination as well. Okay, so what I want to do now is actually jump out of this and jump into the repo, if we can. Because I think rather than sort of show you lots and lots of slides, let's just sort of show what's going on. But I think the important thing to mention, Florian touched on it there, in terms of is this open source? Yes, we're definitely building this out in the open. We bootstrapped it sort of internally to start off with, but we got this published quite a while ago now, and this is open for folks to sort of to use and to contribute to as well, more importantly. So if you've got some experience, or you want to in some of these areas, or you want to contribute that, or you've got some questions, then you can do that within this Node.js reference architecture GitHub page here. Okay, and fundamentally what it is a set of in the project here, who the team is, etc., etc., and then we break down into the components that I mentioned there. So functional, for the functional components, we can look at web frameworks. We sort of talk around the usage of Express, the best usage for Express there, when to use it with Nginx, etc. And I think in terms of what we're talking about today, we're using Node.js in OpenShift. We've also, if you're considering using it, you probably want to look at these sort of best practice for using good containers. So building good non-root containers, what you need to do in terms of the additional commands within your Docker file that you need to use. Our recommendations around putting together multi-stage builds for your Node.js environment, how to use Docker ignores, some side notes on process PID management as well that we found when we've been working in production. You might want to use a wrapper around your Node.js project to stop PID starvation, and best practices around not using npm start, etc. And then I think the other piece that would be interesting to folks is around sort of logging, the best loggers that we found in terms of Pino, which is again an open source library. We're recommending to integrate into your Node.js applications to ensure that you've got good performance, etc. And really sort of the list goes on. And that's all I kind of want to say around that. Just really what I want to share today was like, this is there. As you can see, most of the stuff in here has links now. but we are going to be building stuff. Have any ideas on something that you'd like to see as a topic that isn't covered? If your team are using Node.js, definitely feel free to open an issue or reach out to me directly. I'm on the team that builds this out, so happy to bring that to all the contributors, and we can integrate it into the reference architecture. Okay. And we jump back in then to presentation. Yeah, okay, so the next piece I want to look at then is sort of Node.js on Shift, sort of what's out there, what's coming down the line. So what we're seeing within cloud native development and within application software development best practices in general is we've seen so the move away from monolith into cloud native applications slash microservices. And what we're seeing now is a move from microservices to serverless. And really what that's around is the abstraction that developers are working in is they don't necessarily have to bring a HTTP server and application infrastructure along with their application code. That application infrastructure, the app servers, et cetera, is provided by the platform, and they just provide a blob of code that they want to be executed on a HTTP request. Okay, so it's sort of the next. That's where we've seen the benefits of that are the fact that you as the platform engineer can provide that service up to the app teams. That means that you can standardize that, you can put some best practices into that platform, and the developers get that automatically. It also means that there's less overhead for them in terms of build, deploy, test in their inner dev loop. They can just run their code locally and ask the platform to deploy it as well. And it also means that because you've got fast startup times with Node.js, it also means that you can go for a scale to zero type topology. So when your application isn't being used or when it's being used less, you can ask OpenShift to scale your application down to zero. So you can get the benefits of sort of green computing, if you want to call it that, turned off when it's not in use, which is definitely where, as an industry, that's definitely where we should be going. Okay. And what we like with OpenShift, or what we're seeing with one of the benefits of serverless, is the fact that it addresses some of the top pain points of Kubernetes. Okay, so the developer experience, and it's not as much with OpenShift, but if you use a platform, if you use a Kubernetes platform that isn't opinionated, be it IKS, EKS, AKS, GCP, whatever, the developer experience is pretty tragic in terms of what the developer has to understand before they can deploy something into a Kubernetes. The service definitions, all the YAMLs that come along. If you go onto Twitter, you'll see everybody complaining about YAMLs, developers complaining about YAMLs. I've seen it firsthand in terms of having to educate teams to write their own, to develop their own YAMLs that had to go alongside the applications that were being deployed. So that's a huge pain point with Kubernetes. OpenShift has brought a lot to try and solve that in terms of source to image, et cetera. But the serverless technology that's built into Knative has really addressed that across all Kubernetes platforms, not just for OpenShift. And I would say if you're not installing Knative, which is the serverless technology in Kubernetes, if you're not installing that for your developers into your Kubernetes cluster, you're giving them unnecessary pain. Developers are looking for serverless support as well. So the an approach built by AWS on their Lambda stack, and it's something that they find very, very appealing. So they don't actually want the responsibility of building and deploying application servers, like I say. They just want to deploy their code. I sort of touched there. One of the reasons why we're calling it what I would call Serverless 2.0. Older serverless technologies, such as Cloud Functions and IBM, they were, while they were great from a developer experience, have shortfalls. Some of those shortfalls are the lack of middleware components within the development environment. They were to the rest of the development, to the rest of the application topology. And what I mean by that is, if you've got this environment where you've got a bit of sort of potentially older Java code, you've got some Node.JS code, you've potentially got a DEX, etc., like from an operations perspective, looking after the legacy applications as opposed to looking after the modern applications was completely different. Whereas at Knative, because you can, you've got a lot more flexibility in there. You can as containers and always have one on, but you can also get the benefits of running sort of simple functions as well within a single platform, which is very different than something over in batch, something running on VM, etc., etc. So that's really what I like about Knative. The other aspect of it is, because it's in Kubernetes as opposed to in a proprietary, you can get it anywhere. So it's not just for doing something on public cloud. You can bring Knative on-prem in a third-party data center wherever you want to bring it.
Anton,
So,
can you turn your video off, maybe?
Yes.
Your connection seems to be very bad.
Yeah. Okay.
Yeah.
The kids must be back. I can't find myself here. More.
As much as we like seeing your picture, right? I think it's probably help if the video went off.
Yeah, I'm going to turn that. Right, how's that?
So far, so good.
Yeah, cool. Have I stopped sharing?
Yes, you've stopped sharing. Yeah.
Yeah, sorry, I had to do that because I couldn't find the button otherwise. Okay. So basically, I'm just going to talk a little bit about the internals of Knative now, just to give you an understanding of what it is. You have a concept service, which maps directly to service in OpenShift. Define maps to a route or routes in OpenShift, but it also has this idea of configurations. So you have a configuration of a service, and you can have histories, or you have revisions, should I say, of a deployment. So you can manage things like A/B deployments, rollbacks, etc., etc., and that's built into the Knative environment. So you don't necessarily get that out of the box with the standard containers or Kubernetes. So what I'm going to do now is, rather than talk to the slides, is actually have a walk around. I'm just going to touch on how I deployed OpenShift in. How I deployed serverless into OpenShift, and then just have a look at some of the function code that I mentioned there, some of the new command line stuff now. So I had it open already, didn't I? Yeah. So okay. So this is an OpenShift cluster on IBM Cloud. So we offer sort of all flavors of Kubernetes services. So we offer plain Kubernetes service, but we also offer OpenShift as well. So it's the standard 3-node cluster, 416s, 4 core 16 gigs, and it's sort of point and click provision for your OpenShift console. So you don't have to go through the pain of writing lots of Ansible scripts or anything like that. Just click a button and you have an OpenShift environment. Okay. So what I've done on this cluster is using the operators, and I'm a huge fan of operators. I was initially, when they first came out and I first spoke about them, I wasn't too sure about what the benefits were, but now I've seen them integrated into the OpenShift console. it's super handy way to install features within your Kubernetes, within your environment. I strongly recommend having a look at it. So to install Knative, you click on the Red Hat OpenShift serverless, and then this installs two operators for you, one to do serving and one to do eventing, and then you create instances of those operators. So if we go down to installed operators, you'll see my OpenShift serverless here, and I have you have the option there, as you can see, to create instances. Okay, so I've already created instances within this OpenShift cluster of Knative and Knative eventing. So once you have that installed, you can then download the latest Knative client for the desktop, and you can just build a serverless function. So what does that look like? So you can, and actually I will blow this up a little bit here. Yeah, there we go. So the latest version of the Knative client, which is Knative, shortened to KN, has an additional command in there now called func. And that gives you a set of commands that you can run locally on your local machine in order to develop and build functions. And you can create them. So it will give you can create them in Go, you can create them in JavaScript and Node.js. You can create them in Java, etc., and Quarkus, I would say, as well. And it would provide a full sort of development flow behind that. And then just minus down that a little bit now. And what you get is when you do Knative func create, you get this template project that that provides a skeleton for creating a function as a service. So as you can see here, and this is very kind of important, you just get handles where you write the code that's going to be executed when you get when you get a HTTP call, and you get a context which basically contains the data, metadata around the request and the data in the request as well. And then you can handle gets and posts, and then you can pass that over to an invoke function and do whatever you would wish with that. It's quite important as well. This is sort of standard development flow for software developers. So there's no, once you've got the template, you don't need to do anything outside of what you would do normally as a Node.js developer in order to import packages, etc., etc. This project structure that you have is exactly the same as you would have for a standard Node.js project, and it also has the benefit of not requiring a local container environment in order to build and run these. Okay. So I can run, when I run npm local, oh, sorry, it's npm run local. This will run for me as a standard service on my local desktop. No containers, it's just my local development environment. So it's super friction free in terms of that, okay? Then if you want to use the Knative func commands to do the builds and the deployments, then you can, there's a YAML file that comes alongside it where you can add images and namespaces for your images. So you can tell OpenShift to build and deploy this for you, or you can do what I did for this demo, which is you can still use the standard build and deploy practices that are already built into OpenShift. And that's kind of what I like about this as well, is the fact you've got the flexibility of either being totally in the command prompt with kn func, or you can use the DevOps processes that are built into the platform. Okay, so let's have a look at that. Where did I put this now? Yeah, so within there, say within my projects, what I did earlier on was created this project called kn func demo in workloads. see my topology there. And what was my workload for? There we go, into this. So I've deployed the function into the services as a service. So as I mentioned, you get the services up. It also creates, and as you can see, it's currently at 0 pods, and that's what I mean. You get this scale to 0 type topology as well. And when I create when I created this, it generates a build config for you. Generates a build for you as well, and also creates an image stream for you. And up in the project in networking, it also generates a route for you as well. Sorry, services here. So you get access to the function when it's deployed. So if we go back in and look at the Knative for there now. So if I go application details, apologies, I just a little. I wanted to show you there. That was I want to get the final route for you to show that kind of executing and the so the operator, sorry, apologies for that. So the operator and the serverless operator also acts as a grouping for all the different functionality that you have there. So you can see it, as well as seeing it from a project perspective, you can just look at it from within serving. And I find this, as you can probably tell, I find this the easiest location to understand what's going on. So these are the revisions I've had for the build. These are the routes that I've had that have been set up for the service. Okay, so when I can open this now upon the web, and it's automatically published for me. So I can sort of very simply runs that query. So if I run tests, oh no, let's go. You can see sort of it's there up and running and functioning. And when we go back in to look at the project here, you should now be able to see sort of that it's automatically the pod count's gone up to 1 here. So we've automatically sort of scaled it up, and after a certain amount of time, 3 minutes, 5 minutes, that will scale back down to 0 as well. So you get that serverless aspect to it as well. Okay, so this technology, it's currently in technology, the K-Func is currently in technology preview, but I think it's super interesting in terms of giving the best developer experience for Node.js developers, but it's also going to be available for Java, Go, etc. And there's also a Rust project that's coming along nicely as well. Okay, so to jump back in and just wrap up. So yeah, I mentioned please have a look at the reference architecture as I mentioned. Have any ideas or any questions that you have around that? Any questions about running Node in OpenShift? Feel free to put something in there. I put the demo func app up in my GitHub repository, and in terms of installing the operator, I put a link to the document here, and some more detailed blog posts on sort of what I tried to what I stepped through there in terms of building a simple REST application that you can send events to. Okay, and with that, I will stop and ask if there's any questions. And thanks very much for your time, everybody.
I have the first question. I just went through the GitHub site, it doesn't mention anywhere kind of like what is required in terms of setup for the OpenShift environment. Like, for example, it looks like as if serverless would have to be deployed, right? The operator before I even run this, correct?
Yes, that's correct. For what I just demoed there, absolutely. So the reference architecture is around the components and the libraries that are in the Node.js ecosystem. They don't necessarily, you don't have to run serverless in order to use that reference architecture. That's just, if you're running Node, this is what we recommend that you should use from an application library point of view.
Got it. Okay. It looks very interesting. I have to say, I don't know how many JavaScript developers are here on the call, but I certainly am. I mean, I don't do Java, so I find it personally quite interesting. Did you ever run into any issues with SCC? So the biggest problem that I've seen with using Node.js and OpenShift, what I quite often see is applications have to have root access, like down to the level of containers need to run as root, and then I get problems with SCC on OpenShift. Is that part of the Node.shift project? Is that resolved, or is basically the expectation that I start from scratch with a net new application and basically just avoid that from the beginning on?
Yes. So if you look at the build systems within OpenShift for Node.js applications, it sets the correct permissions for you, so you don't hit that problem. You shouldn't have to run. I haven't come across that, Florian, I'll be honest with you.
Okay.
With the folks I've been working with, the Node.js applications, I've never hit, oh, I have to run it as root. There's sometimes a misunderstanding that, so for whatever reason, know that to run, you just go and have that conversation to guide them to say, listen, you can't just up the port there. It's getting mapped anyway. Sort of, there's no hard requirement there. You sometimes hit things with with files as well, when they're, even though it's ephemeral storage, they still want to write something local. So yeah. I've had to work with them to write stuff to temp, but that's more of just understanding the different storage aspects of a Kubernetes platform than anything else. They're the two things that I can think of that have caused SEC stuff. And the answer to me, unless you're doing something, I always get nervous if devs are asking to run as SCC or asking for those patches. I always get nervous about that. It's usually a smell that something's not right.
Yeah, I've mainly seen that taking existing code somewhere off GitHub, trying to run it on OpenShift, and then that's usually the first permission issue that I would run into. Yeah. Pretty standard is that I don't have the right permissions. But obviously, like if it's my own code base, I should be aware of it.
Yeah. Yeah, and I appreciate the fact that everyone on the call wasn't sort of a JavaScript engineer, and that's kind of why I was sort of did the review of what Node.js is and why you'd want to run it on a platform such as OpenShift as well. So hopefully, again, the idea being of this, that if the people you're working with, if you're working with front-end engineers or full stack engineers, there's a good opportunity to support them with an OpenShift environment as first-class citizens. That's definitely one of the reasons why I wanted to do this talk, was to share that rather than just to the dev community. Because most of my talks are just with other JavaScript developers telling each other how great they are. It's great. It's great to come and bring it to a wider audience, and I hope it was of some use.
So maybe something slightly out of the scope of your presentation, but what I've also seen is that more and more dev teams are looking at polyglot applications and having some sort of component in there, which is running Node.js in the backend, and then it might tie in with a couple of Java services which are already existent. I haven't looked at it in enough detail, but in authentication and authorization is quite often a big question. How am I going to handle authentication and authorization between these applications, making requests back and forth is that something where kind of the Node.js and the reference architecture looked at all, or is that kind of not covered by it?
It will be. So we've got a section under APIs, and we plan to cover it under that. Yes, and that has come up with discussion, because you've also got, you also need an opinion on, should actually that be handed off to a sort of an API management component? Should that be in your service mesh? Should it be, where should that live, and what's the opinion on that, you know? So you've got kind of what best practices would be there, but you've also got, okay, what are we seeing sort of in production practice as well? And a lot of that is going to depend on the security posture of your organization, what's already in place, what are you currently using for your authentication and authorization, and mixing them in, and aligning really your practices with that. I think, to me, that's not really a question around polyglot or heterogeneous code bases. That's more a question on sort of how you're going to do your microservice or your API integration. And speaking with my IBM hat on, I'd strongly recommend that you buy an API management solution from a trusted vendor.
Taking my open source hat on, I strongly recommend using Con, because everyone is using Con at the moment as an API gateway. I hope this is not recorded for Red Hat.
Absolutely. So, and we see Con, we actually have a Node.js based API management called Loopback that provides sort of a similar level of features as Kong would do as well. So again, that's open source. You can go and knock yourself out with that. So yeah, there's many things that can kind of get you there. It's more how are you going to enforce are you going to use JOTs, JWTs? Like, how are you going to go about doing that? There's a lot of different conversations, and security and all those folks would want to know, within an org.
To me that looks very interesting. I hope we have at least one or two more JavaScript interested people here on the call, which were interested in that, because I think that's brilliant. I think there's a lot of people, even people that I know that are kind of front-end developers or JavaScript developers, for whom that is going to be very interesting.
Yeah, and I think it's for me, we're starting to see, like I was saying at the start, we're starting to see Kubernetes mature into. We're starting to see OpenShift mature from just being an operations focused sort of product. And I know that's probably a bit unfair in terms of the capabilities you've had for developers, but the feedback that you've got from the community is starting to feed in, and that dev experience is really starting to become first class. Using Kubernetes, any Kubernetes instance or type, like 2 years ago, it was painful, like I was saying at the start, and you can see the effort going in. It's great to see, Because we're wandering around saying, on platforms as a service, fantastic, and all talking about developer acceleration and time to market, etc., etc. And it was and is true. It's just there were some very jagged edges in parts of it.
Just having looked now at the reference architecture as well, so there's work being done on the references to CI/CD as well, correct?
Yes, absolutely.
And is that going to be, like, have you seen anything? Is that going to be focused more around kind of native technologies or Kubernetes native technologies like Tecton, for example, or is it going to be more Jenkins standard build processes?
So probably what it's going to be around is asset management, I would say. So we haven't spoken as much about that as we have about the APIs one, and the sort of security auth integration. So I can't really give you a heads up there, Florian, but I would say if there is a particular aspect that you'd like looked at, then feel free to drop it into the GitHub and say, as part of CI/CD, can you cover X, Y, or Z? But I would say, given the focus of the group, the initial steer would be towards sort of internal NPM registries, when to use sort of shared packages, over bringing that package into a specific project, that type of thing. And it will bleed into some of the build practices as well that we saw in the container lifecycle. So,
okay.
But if you've got something specific, like I say, fire a question at us.
Pull request incoming.
Excellent.
Brilliant. Are there any other questions? No, cool. If people have any requests for topics for the next meetup, so it looks like as if the Irish government is easing restrictions in time so we can finally meet in person. So the ideal plan is, if you haven't seen it, Red Hat is going to have something that we call Red Hat Summit Connect, which is our annual event held mid-November in person in Dublin. So the plan would be to run the next iteration of this meetup in person at the 11th of November in Dublin. So obviously there's going to be invites and stuff going out. And if there's any specific topics that you would like to cover, I know we've looked at serverless, we looked at Argo CD, we looked at CI/CD, we looked at Node.JS, we looked at OpenShift and OpenStack. So anything that is developer or operations focused, we're more than happy to cover. Just let me know, let us know, and then we can organize and find people that are interested in talking about it. And obviously, big thank you to Anton, Sean, and Jeff, even though Jeff didn't really do anything, for today's meetup.